What's up, guys? Coach Podman, as you probably already know, is out for the day. Home with sick kids. So made another video for notes. Starting a new video or a new unit. This one's logarithmic functions. Before we get into that, first of all, your grades should be as up to date as possible. So any makeup work that you put in, and then the latest test is in there. Later this week, we'll take a peek at those tests so you guys can see how you did. If you missed the test on Friday, make sure you're coming up with a time to come in. I mean, I would honestly suggest coming in, probably going to Miss Gandhi or Miss Miller and seeing if they can do it if you can do it on Monday. Other than that, I'll be after school on Tuesday and Wednesday, so those will be your opportunities for that. So let's go ahead and get into this. Logarithmic function. This whole first page, I mean, you guys know how to read, so, you guys can, tend to, you can read. But I'll just highlight some important information here. Essentially, what the logarithmic function is it's the inverse of an exponential function. So just like how an exponential function has a base, like in this one, the example they have, the base is 2. A logarithmic function also has a base. Okay, so so that just basically means that parent functions are based off of what the base is. So when the base is something greater than 1, then we get something that looks like this. So if our exponential function, this is 2 to the x, we're pretty familiar with that one, is here, then we reflect it across the line y equals x, we get the logarithmic function, which is right here. Some features. The domain and the range flipped from the exponential function, and that makes sense because they're inverses. So domain is from 0 to infinity. We're not including 0. Another way to write that would be x greater than 0. Okay, not using interval notation. The range would be negative infinity to infinity, or all real numbers if we're using again, our not interval notation. It's an increasing function too. It's always increasing. It's always getting bigger. But instead though, we've changed from having a horizontal asymptote at y equals 0. So remember, it doesn't cross the line y equals 0. To now, it's changed to a vertical asymptote now. So that does actually change the function up quite a bit. Now, instead of it not crossing the line y equals 0, it doesn't cross the line x equals 0. So it can't be, you can never have a negative output, a negative input into the function. You can't put negatives in there. Essentially, what the log function does, like the whole point of it, like why it is what it is, or what does it actually do? Essentially, what it does is it says whatever input you put into it, it essentially is saying, what would you have to raise the base to? In this case, it would be 2. What would you have to raise? What power would you raise to get the number that you input, that x? So, like, let's say if I throw in like log, like if I say y equals log base 2, and then I plug in a 2. So the question is for the output for y. So in this case, I put x is 2. The output would be, what number would I raise that base of 2 by to get 2 back, to get that as a return, to get 2, my input, as a return. And so in this case, my y would be equal to 1, because if I raise 2 to the 1 power, I get 2 out. Okay, so it's basically exponents in reverse. That's essentially what it is, like an exponential function in reverse, which makes sense since they are inverses of each other. Let's do another example just to hammer that home. So if y equals log base 2 of, say, 4, okay, the question is, for the output y, what exponent would I have to raise 2 by to get the output of 4? Well, we should know that if we raise 2 to the second power, then you get 4. So my output in this case would be 2. Okay, so that's kind of the idea with that one. Just like with exponential functions, the log functions, when you get a base that is a fraction, it changes things up a bit. So when we have fractions here, what we're going to do is essentially when our base is a fraction, just like with the exponents, it started off big and then leveled out instead of leveling off and then getting big like the other one. And so when we get the inverse of our log base of, like in this case, it's a half, it starts off big and then gets smaller again. Okay, this is also a decreasing function at this point. So whenever you've changed it, now it's always going down as x gets bigger, y gets smaller. Again, there's some changes compared to the exponential function in the domain and range. It's really similar to up top. 0 to infinity for the domain, range is negative infinity to infinity. We've got a vertical asymptote at x equals 0 again, and again, like I said, it's a decreasing function. So again, what we're saying is okay, what do I have to raise 1/2 to get whatever number x that I plug into? So it's the same kind of thing, just now it's decreasing with that fraction. Little typo here at the bottom. It says, notice if the base of the function is greater than 1, then the graph is increasing. That is correct. If the base of the function is between 0 and 1, then the graph is increasing again. No, that's a typo. That should say decreasing. So that's, yeah, a little typo we have there. Oops, there we go. Now I can see it. Okay, so that's just a little typo. So how do we graph a log function? Well, since we know that it's the inverse of an exponential, what we can do is we can graph the exponential like we already know how to do, and then we can just take the inverse by switching the x's and the y's for all of our points, and then that'll give us our log function. So it says start by graphing y equals 3 to the x, then graph its inverse. So we'll graph y equals 3 to the x. Remember, there were 3 points. There was -1, 1 over our base, or a as we usually call it. So it'd be -1, -1/3 would be one of those points. They all went through 0, 1. And then they all went through 1 and then a, or the base, which would be 3 in this case. So what we're going to do is we're going to graph those 3 points. And then 1, 3. And that'll be our exponential function. All right, so there's our points. 1, 3, 0, 1, and -1, 1/3, right there. Okay, so that's our exponential function, y equals 3 to the x power. Then it asks us to graph the inverse. So I'll use a different color for the inverse. Now, when you're graphing an inverse, what you do is you switch the x's and the y's. So if this is 1, 3, we're going to have 3, 1. So that would be right here, 3, 1. Okay, we have 0, 1, so we'll have 1, 0. That one will go here. And then we'll have -1, 1/3, so that'll be 1/3 -1. So 1/3 is the x, and then the y is 1. So that would be about right there. And again, it has a vertical asymptote, so it's going to hug the y-axis now. And then this guy kind of levels off, sort of. It kind of shoots to the right instead of shooting up. So it's like this sort of shape. Okay, and then this will be our log function. Okay, so actually let's label the points. 0, and then that one is 1/3 -1. Okay, so what's nice is you can always fall back on just graphing your exponential function with that same base for a log if you happen to not remember these, but it's kind of nice. Y equals, and then here's the equation. This is going to be log base 3 of x. So it's going to have the same base, okay, but this is just what it looks like. And over here again, y equals log base 3 to the x. And before you guys say anything about my L, I've already wrote it a couple times. I write it as a cursive L so you can tell it's an L. If I draw an L, you won't be able to tell it's an L. You'll be like, why is there a random 1? Okay, so just getting ahead of that one. Domain and range of this guy, again, it's 0 to infinity for the domain, or -infinity to infinity for the range. Or we could say x is greater than 0 and all real numbers. Okay. All right, so with that, we can define, just like how we had negative, these 3 points that we had to have for the exponential function, we can write these points in a general sense for the log function. So like in this case, we had 1/3, -1, we had 1, 0, and then we had 3, 1. Okay, so in a general sense, so if you have y equals log base a of x, so any a, then the 3 points that you can draw on the graph would be that would be 1/a -1. It'd be 1, 0, and then you'd have a, 1. Those would be your 3 points that you can use as a reference and to get your parent function, and then you can kind of shift them from there depending on shifts, because that's going to be our next section here, is using those for shifts. So just like with the other ones, we can shift it, right? We can move it up, down, left, right. And actually, let's just do it like this. Let's leave the 3 points up there. All right, that looks good. A little more. There we go. Okay, so we'll leave the 3 points up there. Then again, we can shift it just the same way that we shift all functions. So like the +1 on the end, this one's going to go up 1 because it's the same sign. So we'll just take all those parent functions that we did up here, because we did log base 3 up here. This is log base 3 again. So we'll use those points and we'll move them all up 1. So like that first one was 1/3 -1. That'll be 1/3 0 on that one. The other one was 1, 0. That turns into 1, 1. And then we had 3, 1, so that'll be 3, 2. And again, it's just hugs the vertical asymptote here and then kind of flattens out that way. All right. So that's our general shape. And again, our asymptote is at x equals 0. That's where our horizontal asymptote is going to go. So our transformation is up 1. Okay, our domain did not change. We're still 0 to infinity, and our range also did not change. -infinity to infinity. Okay, and then we can move on to this one here in the parentheses. Okay, the last time it was when it was with the exponent, and then when it was without. This one we're governed by parentheses. When we're in the parentheses, it's a left-right action. So in this case, -2 is the transformation. So since we're with the x in the parentheses, this is actually going to go opposite sign. This is going to go right 2. Okay, so that's going to be our transformation. And so we can take our parent function from up top and we just move everything to the right 2. So that 1/2 negative, or 1/3 negative 1 will move from here to 1, 2, we're going to the right 2. Okay, and then let's see, that other point was 1, 0. So that's 1, 2, be right there. And then the other point was 3, 1. So 3, 1's right there, 1, 2 right there. All right. So my vertical asymptote was at x equals 0 before. It shifted over to the right with everything else. So now my vertical asymptote is at x equals 2. All right, it goes right 2. These two have to match. All right, whatever that transformation is. All right, and it'll look sort of like that. I don't think I flattened that out enough, but that's all right for now. And that's kind of the idea. So now my domain has changed. It's not 0 where we're stopping here. Now our stopping point is at x equals 2. So that's going to be 2 to infinity. And then our range is going to be -infinity to infinity. Nothing can affect our range. Okay, just like how last time nothing can affect our domain with the exponentials. This one, nothing can affect our range. All right, here's one with 2 shifts. One on the inside. So that's my left-right action, and actually it's opposite sign. Good job, Podvin. Left one, and then this one out here. This is going to go. I almost wrote up. Down 2. Okay, there we go. All right, so it's left 1 and then down 2. All right, so let's take all those points and we'll go. And it doesn't actually matter which one we do first when they're both transformations like this. So Let's see, so left 1 and then down 2. So that one would be down there. This one's going to go left 1, down 2. This one's going to go left 1 and then down 2. There we go. Okay. Our new vertical asymptote, I got to get used to saying vertical now, is going to be x equals -1 since we went left 1. So that's where we'll hug the line there, and then it'll flatten out that way. All right. Ugh, that one was kind of ugly. Domain needs to match my vertical asymptote, so -1 to infinity. These numbers have to match. And then we'll have our range, our never-changing range for these ones, -infinity to infinity for that part. All right. Now let's go ahead and graph on the other side. Do one with a fraction. Okay, so we're between 0 and 1 is our base this time. So we'll graph 1/3 to the x power first. Our points for that one are going to be -1, 3, 0, 1, and then 1, 1/3. Okay, so we'll graph those. Okay, again, this on the exponential function, we've got the horizontal asymptote. This time it's just decreasing, so it starts high and gets lower as x gets bigger. Okay, so we've got that horizontal asymptote like normal at y equals 0. Okay, if we do the inverse, so we are going to be flipping all of these points. It'll be 3, -1. We'll have 1, 0, and we'll have 1/3, 1. Okay, so let's go ahead and plot those. So 3, -1, 3, -1 right there. Okay, and then we got 1, 0, which will be that one. And then we'll have 1/3, 1, so that'll be right there. And these kind of cross, so this gets kind of weird on these ones when you draw them together. This will be at x equals 0. Okay, from here it'll go hug that vertical asymptote going up. And then as x gets bigger though, it's going to actually get smaller and it kind of levels out, but it's still going to keep going down. That's the weird part. It looks like it levels off. It's kind of like that square root function, like how it levels off, but it's still kind of technically going up. This one technically still going down, even though it levels off pretty hard. There is no horizontal asymptote for my pink one here. Okay, this guy is going to be pink guy, y equals log base 1/3 of x, and then this was y equals 1/3 to the x power. All right, and that's pretty much it. So again, it's y equals log base 1/3 to the x. Our domain is just the same as the other ones. It's 0 to infinity and then -infinity to infinity for the range. All right, now let's go ahead and do some transformations of these guys, and then we can check that out. So, some transformations. Again, we got base 1/3 for these ones as well, so we're going to go ahead and keep those just the same. Let's zoom out so we can see everything. There we go. Cool. All right. Again, outside parentheses, that's going to be my up-down direction, so this is going to be down 1. Alright, down 1. Alright, so there we go. So we'll take all of our points and we'll just shift them down 1. That means that my vertical asymptote is not going to change. Let's see, so this one was 1/3 1, so it'll be down 1. This other one was 1, 0, so it'll be down 1. And the other one was 3, -1, so it'll be down 1, so it'll be right there. So again, we'll kind of just hug that vertical asymptote there, sort of level off, but not really, not technically, it's still kind of curvy. And that's it, it just got shifted down. Domain should not change in this case because we didn't go left or right. So it's 0 to infinity and then -infinity to infinity for the range. And that's pretty much sums it up. Inside the parentheses, this is our left-right action, opposite sign, so we're going to be going left 2. All right, so we're going to take that horizontal asymptote, or sorry, the vertical asymptote, I keep saying that. We're going to shift that right there to x equals 2, negative 2. And then we'll just shift all of our points too. So we had, what did we have? We had 1, 0, I remember that. So that's going to shift to the left too. We had that one that was 1/3 1, which was right here. So that'd be 1, 2, so right there. Let's see, we had 3 negative 1, so it was 1, 2 right there to the left. Hugging the line, sort of level off. Oh, that one was uglier. Okay, domain on that one definitely changes. We're going to negative 2 now, so it's negative 2 to infinity. And then my range is negative infinity to infinity. Okay. And then we can do this last one. So inside the parentheses, opposite sign, so that's right 1. Outside, same sign, up 2. So right 1, up 2. That is the plan. So we'll take these points. 3, negative 1, we'll go up 2 to the right 1. Doesn't matter which order you do these ones in. Shifts up and down, left and right. Doesn't matter the order. Let's see. So then we've got, what was that? 1, 0. Yeah, 1, 0 is going to go up 2 to the right 1. And then we've got that 1/3 1 up 2 to the right 1. Right there. Okay. Since we went to the right one, my vertical asymptote, goodness, has now gone to the right one. So that's going to be x equals 1. So that's where my vertical asymptote is going to be. And then that's what it'll look like. Again, my domain is going to change because we went to the right one. 1 to infinity, and then we got negative infinity to infinity right there. All right. Just as a little bonus for getting through the whole video, and this is notes, so you're obviously not going to turn it in, but I'm going to check it on Tuesday. For bonus, go ahead and buy your name. So you write your name. Okay, you write your name. Box it. Okay, just box your name. There's your Easter egg. Little bonus for a daily grade this week. I'll just add some points or something. I haven't figured out what it'll be, but it'll be some little bonus for you. Okay, appreciate it. See you guys on Tuesday.